All right, welcome back. Today we're looking at 5.2, and this is just a single day. It's not all that complicated. Um, and honestly, probably about two-thirds of it or three-fourths of it revolves around you understanding how to do review content. So, I mean, hopefully it'll be okay. Let's get into it. 5.2 is talking about solving quadratics using square roots. So instead of factoring, all we're going to be having to do is square root things. And we're going to start by reviewing square root properties, and we will also look at some things that aren't properties that are commonly thought to be true, which are not. And we're going to be combining and simplifying square roots, and then we'll be solving quadratics using square roots. Hopefully this lesson will go fairly quickly, maybe in the 20-minute range. But anyway, let's get started. So, simplifying square roots. This is best put in your notes, in my opinion, by doing an example and explaining what you're doing and why you're doing it throughout the example. I typically use this method a lot in when I was doing my own notes in my math classes in college, where I would have a complicated example like some partial derivative, and I would be explaining what I was doing throughout the example, and that's a good way to do it. It helps you understand better, and it can teach you how to do other types of examples by reflecting back on the example. So that's what I encourage you to do. So we'll do each of these steps, and I would write them down if I was you as you do them. So we've got the square root of 50. So the first thing we want to do is you have to look at the number you're given. In this case, it's 50, and we're trying to simplify this, simplifying square roots by hand. So what you want to do is you want to break the number into perfect square factors. So the idea here is you want to break 50 into a factor pair, like 1 and 50, 2 and 25. 3 doesn't go into 50, 4 doesn't go into 50, 5 and 10, right? Break it into a factor pair where one of these numbers, you know the square root of. This is what will be helpful to us. So this is what I mean by break the number into perfect square factors. So you want to choose one of these factor pairs where you know the square root of one of these numbers. So, and not one, because that's not helpful. So you don't know the square root of 50. It's not a whole number. You don't know the square root of 2. That's an irrational number. We do know the square root of 25. So this is the one we want to choose. You choose this factor pair because you know the square root of one of the components here. So you've got 2 and 25. So 25 and 2. And what happens is when you break it into 25 and 2, then it's still the square root of 25 times 2 under the same radical. Because 25 times 2 is just 50. I'm sure you guys can agree that this is the same thing, right? So this is where one property of a square root comes in. This property that we'll write out here in a minute says that if you have a product under a radical, you can separate the product into different radicals. So this could be equal to the square root of 25 times the square root of 2. Notice I've got to multiply here, so that's a product, and it's under the radical. So you can break it into the square root of 25 and the square root of 2. Like they can go into their own little houses here. And now that they're in their own little houses, we can simplify the square root of 25 because we know that the square root of 25 is 5. And so you get 5 times the square root of 2. And the square root of 2 cannot be simplified any further because you can't break 2 up into two different numbers where you know the square root of 1, right? So that is as simplified as the problem gets. So let's try to simplify, so you're done there, right? So let's try to simplify these two problems. Give me just a second. You write this stuff down. Man, my my illness has gone away mostly, but my allergies are starting to get bad. So it's just trading one problem for another. Anyway, so let's try to simplify these expressions here. So I'll help you with this one here. You want to try to think of what two factors you can break 18 up into where you know the square root of one of those numbers. So 1 and 18 you never want to use because you don't want to break it into 1. 2 and 9, 3 and 6. So do you know the square root of one of these numbers? Why, yes, Mr. Darwell, it's 9. That's correct, student. 9. You know the square root of 9. It is 3, right? So you want to choose 9. So you've got 9 and 2. And the reason you choose these problems, right, is because you can break this into the square root of 9 times 2, which breaks further. If you want to skip this step and skip right to this one, you're more than welcome to. It breaks up like that, and that gives you that gives you 3 times the square root of 2, because the square root of 9 is 3, and the square root of 2 stays the square root of 2. All right, you guys following along now? So now you get to break 605 up into two numbers where you know the square root of one of them, and this is going to be harder. So my advice to you, pull out a calculator. Here's my calculator. You've got 605. Start dividing 605. Calculator. All right. Start dividing by numbers you know the square root of. So 605 divided by, let's say, 4, because we know the square root of 4. All right, that doesn't come out evenly, so keep going. And you're going to keep going even if it does come out evenly for a little while here. So then divide by, that's 2 squared. That's, you know, the square root of 4 is 2. So the square root of 9 is 3. Doesn't come out evenly. The square root of 16 is 4, and you kind of want to climb up. That does not come out evenly. The square root of 25, that won't come out evenly. Then the square root of 36, we know, so you want to divide by 36. That does not come out evenly. How about, so that was going to be 6, so what's the square root of a value that gives you 7? That's 49. So does 49 come out evenly? No, it does not. Is this 605? Yeah, it is. Okay, so we'll get there. 605 divided by, the next one would be 64. Does not come out evenly. Next one would be 81, because the square root of this is 8, the square root of this is 9. We're going to climb up. 81 doesn't come out evenly. Now 100's not going to work. Now 11 squared is 121. Hey, we have a winner. 121. The square root of 121 is 11. So that's the value you want to choose. You want to choose 121 and 5. So you pull out 121 and 5. And then you'll square root these. And that gives you 11 times the square root of 5. And that's it. Square root of 5 can't be simplified any farther. All right, so you guys doing okay here with this simplifying process here? All right, so let's look at some of these square root properties. Now, I would just write, I would listen and write down the basics of this. It's not too much to write, actually. The first property we've already been using, and that's that if you have a product underneath a radical, you can separate the pieces of the products into their own radicals. We've been using this. The next property says that if you have a quotient, a division happening, so here was a product, multiplication. If you have a quotient under a radical, you can separate each piece of the quotient into their own little houses, their own radicals. So products can go in their own radicals, pieces of quotients can go in their own radicals. Now the final thing is treating, it's the property that says that you can treat, well, in layman's terms, you can treat the square root of some value as a like term. So the idea here is if you had 5 square roots of 2 plus 7 square roots of 2, that would equal, like, this is like 5 apples plus 7 apples. You have 12, apples, or square roots of 2. This is the property at play here. If you have multiple terms where you have the same square root, you can combine the terms just like they're like terms. Right? That's the idea here. Now finally, the thing that is not a property that students oftentimes think is a property is that if you have a sum underneath a radical, that they think you can separate the sum up into their own radicals as well. And this is not true. And you can see this simply by looking at this. So you think the square root of 50, that is equal to the square root of 25 plus the square root of 25, right? Well, excuse me. Here we go. There we go. I misspoke. So the square root of 50 is equal to the square root of the quantity 25 plus 25, right? Because that is just 50. We agree with this, right? So this property is saying that, or the idea that this is true claims that the square root of 50 is also equal to the square root of 25 plus the square root of 25. But the square root of 25 is 5, and the square root of 25 is 5, and so this should be 10. But if you see, the square root of 50 is not 10. The square root of 100 is 10. The square root of 50 is 7.07-ish. So clearly it's not 10. So this property is not true. It's almost never true, actually. I don't know. There's got to be a situation where it is true. Definitely with, well, I don't know. Surely there's a situation where it's true, right? I don't know. But anyway, it's definitely not true. So you should not be using it. So let's look at an example here. Solving or simplifying these square roots. So now that we have knowledge of what to do in terms of what properties work and how to simplify square roots, we need to do so. So first off, can the square root of 6 be simplified? And the answer is no. There's not a number that goes into 6. There's only 2 and 3. There's not a number that goes into 6 that we know the square root of. That's a whole number. Not 2, not 3. So that we can't break that up. So square root of 6 is as simplified as that gets. So right off the bat, I've got 1 square root of 6 plus 7 more square roots of 6. So that is 8 square roots of 6. All right, looking good so far, right? You had 1 of the square roots of 6, and you added 7 more square roots of 6, so now you have 8 square roots of 6. Now 54, on the other hand, can be broken down. 54 breaks into 9 and 6. So you take the square root of 9, the square root of 6, and you get 3 times the square root of 6. So I'm just simplifying what I can, combining what I can, and sort of just going with the flow, okay? So what we have is 8 square roots of 6 minus, and this is 3 square root of 6. Hey, look at that. We can combine these. They're like terms again. So 8 minus 3 is 5 square roots of 6. There's your problem. There's your answer, I mean. Did you guys follow along? So these could combine because 1 plus 7 is 8, and they were still square roots of 6. So they were like terms. And then the square root of 54 could be simplified, and you have to think, we've done this several times up here on these examples here. You just break it down into a number you know the square root of, and that was 9 and 6. And then we know the square root of 9 to be 3. That's why we chose it. And it just so happened, well, not just so happened, I made this problem, to where it is also the square root of 6. And so these can combine again, like terms. All right? So let's solve square root equations. This is not really using that same information quite yet. This is going off in another direction, but this is really, well, I don't know. Students find this to be fairly simple. All right, I'll put it that way. In general, students find this to be okay. So have a positive attitude, and I'm sure you will too. So you want to use this method when you have a single variable being squared or will be squared. So the idea here is you want to isolate the variable, square root both sides, remembering the plus or minus, and then simplify if necessary. So you're like, okay, well, I have no idea what is going on here. Wow, I gotta watch my language. All right, so then let's do it. All right, I got sidetracked. I almost messed up. So here you want to get the variable by itself, the x by itself. So you need to get the 3 to go away and the 2 to go away. So you want to add 3 to both sides. So let's see here. Let's isolate isolate x squared. So you want to add 3, and you get 2x squared equals 18. And then you want to divide by 2 and divide by 2, and you get that x squared equals 9. Great. So now, this just like we divided by 2 right here to get rid of it, to get rid of a square, you square root both sides. And when you square root the other side, you must remember to have a plus or a minus before the square root. And I'll explain why after we're done with the problem. Take my word for it for now. So the square and the square root cancel each other out. They're like the quote unquote like inverse operations. And you end up with x equals plus or minus the square root of 9. And what's the square root of 9? Well, the square root of 9 is 3. So you get the plus or minus the square root of 3. So this has two solutions. X equals 3 and x equals negative 3. And I'll explain now why we used a plus or minus here. So back over here, back right there, we had x squared equaling 9. So if you try to solve this in your head and you think, what number times itself gives me 9? And you might think, oh, well, 3 squared is 9. Well, yeah, that's definitely true. 3 squared is 9. However, it's not the only value that when you square it, it gives you 9. There is also negative 3. Negative 3, when you multiply negative 3 times another negative 3, the negatives cancel out and you get 9 again. So this is why you have to remember this plus or minus, because it works its way into the solution where you have a positive 3 and a negative 3, okay? So always remember the plus or minus whenever you have to square root, okay? This will come up again. So that was it. That's the problem solved. It's basically just solving a two-step equation and then square rooting. That's it. Man. Sorry, I've got a killer stretch and yawn. All right, now, let's go ahead and move on. Oh man, I promised you a 20-minute lesson. All right, we gotta go. So this next problem, again, get the x squared by itself. So subtract 3, and you're gonna have x squared over 16 equals 24. So guys, the way you get rid of denominator numbers is to notice how you're dividing by 16 right here. So you want to multiply by 16. Multiply by 16. Yeah, that was terrible. Multiply by 16. And you're going to get x squared equals whatever 24 times 16 is. We're going to need to know that, actually. 24 times 16. Yeah, I can't do that in my head. 24 times 16. 384. Of course it's 384. How could I be so stupid? So, sorry, that's x squared equals 384. So now you square root both sides. Remember the plus or minus. And now we get x is equal to plus or minus the square root of 384. Now, I assume 384 can be reduced further. I assume that you can break this up into different square roots to simplify the problem. Just like we simplified up here, right here, we simplified the square root of 54. Let's try to simplify the square root of 384. So let's do this fairly quickly here. 384 divided by, let's do 81. 384 divided by 121. 384 divided by 144. 384 divided by, let's see here, 64. 64 and 6. Boom, look at that. Found it. So you want to choose 64 and 6. And so that is going to be, the square root of 64 is 8, and the square root of 6 is just the square root of 6. And so you get x equals plus or minus 8 times the square root of 6. So I want to be very technical here. Plus or minus, what that represents is two solutions. You have x equals 8 times the square root of 6, and negative 8 times the square root of 6. Both solutions, okay? Now, finally, last problem. And it's good that we do this because we'll need to. I'll say let's not simplify this one because we're cutting right into our my promised time. So here, Instead of getting the x by itself, because it's embedded in this parenthesis, get the parenthesis by itself. So move the 7 and move the 3. This is the idea you'll be doing a lot. So subtract 7, and you get 3 times the quantity x minus 5 squared equals 36. Now you divide by 3. Don't distribute in. You can't do that. Currently, this set of parentheses is being squared, and exponents come first, right? Exponents come before multiplication, so just divide it away. It's simpler anyway. So you get x minus 5 quantity squared is equal to 12. Now that we have our thing being squared, you can square root both sides to get rid of the square. And you get, the square goes away, so you have x minus 5 equaling plus or minus the square root of 12, right? Now, I'm not going to simplify the square root of 12, though it can be simplified. And I'm just going to add 5 to both sides. Add 5. And so you get x equals plus or minus the square root of 12, and then plus 5. So this can be rewritten as this. This is how you'll most commonly see it, where the 5 I moved in front of the plus or minus. That's okay, but both are true. All right, so there's your lesson. Here's your homework. I mean, you guys know the drill, right? Like, this is not anything new for us. Let's go ahead and keep booking on through it. I will tell you that chapter 6 is slated for the last chapter of the semester. So depending on what time it is right now, we might be ahead of schedule, hopefully. Anyway, whatever. We'll get to that when the year starts, and you guys are already there. So what have I been doing?